So last time we talked about how to make a box plot. This time, let's talk about interpreting box plots. On this page of notes, each box plot represents the same data as the dot plot that's right above it. So let's look at the first one over here on the left. It's symmetric. In fact, this one is perfectly symmetric. That means that the left side is exactly the same as the right side. We don't need our data to be perfectly symmetric in order to say that it's symmetric. It just needs to be pretty close. However, this one's perfect. So let's see what we can see about this data from just looking at our box plot and our dot plot. So I've got a list of things down here that I want to find. I want to find the mean, the median, the mode, the minimum, the maximum, the first quartile, third quartile, the range, and the interquartile range. That sounds like a lot, but a lot of this we can find just by looking. So for example, the minimum, that would be 1. All right, the maximum is 9. Our first quartile is 2. And our third quartile is 8. See, those are the ends of our box. Those are the ends of our interquartile range. And our median, or our second quartile, is 5. So just by looking at our box plot, we were able to get a lot of information. In fact, we could use this to figure out our range and our interquartile range. Our range is just going to equal our maximum minus our minimum. So that's going to be 9 minus 1, and that's 8. Now let's talk about our interquartile range. That's going to be our third quartile minus our first quartile. So in this case, that's 8 minus 2. And that's 6. Hey, so far this has been pretty easy. Let's talk a little bit about the mean and the mode. We can't tell the mean and the mode from the box plot because it doesn't show us exactly where the data points are. For that, we're going to need to look at the dot plot. Now remember, the mode is the one that happens the most frequently. So in this case, our mode is going to be 5. That's our tallest bar. So I'm writing down 5 there. And for our mean, I'm actually going to need to add up all these values and divide by the number of values. All right, so I've zoomed out so that I have space to add up all these values. There they are. So when I added them up, I got 45, and I notice I have 9 data points. So 45 divided by 9 is going to give me a mean of 5. Great. So now that you know how to do it, why don't you try the next one, the one that is skewed right. So now you're doing the middle one. Pause the video, and then when you're done, come back and check your work. Good job. So here are the values we can get just by looking at the box plot. Subtracting our max and our min, we get that the range is 7. And subtracting our third and first quartiles, we get that the interquartile range is 4.5. So we would use our dot plot to get our mean and our mode. And in this case, our numbers sum up to 35. When we divide by 9, we get 3.8 repeating. And our mode is 2, because there are 3 2s in this data set. Now give the final example a shot. And on our third example, here's the information we can get from just looking at the box plot. Now let's use our dot plot to get the other 2. First of all, looking at the mode, I see I actually have 2 modes here because 7 and 8 both have the same number of values and they both have the most at 2. And then adding all of these together, we get 55, and dividing by 9, and then 55 divided by 9 is 6.1 repeating. So this is the basic analysis that you could do to compare any 2 box plots. So now we can really easily look and see which one has the biggest median. The third one, right? It has a median of 7. And what about the largest IQR? Well, that would be our first one right here. It has an interquartile range of 6. So it would be very easy to compare these on any criteria that we want to now that we've gotten organized. The final way that I want to talk to you about this data is using the word skew. So at the very top, we said that our middle graph is skewed right. That means that as you go to the right, it's spread out. So it kind of spreads out to the right. Our third graph, we say, is skewed left. That means that the data is spread out to the left. And our first box plot was not skewed at all. We consider that one to be symmetric. You can actually tell whether data is going to be skewed right, skewed left, or not skewed at all just by comparing the mean and the median. I just added a green X to each box plot showing where the means would be. And what I want you to notice is that when the data is symmetric, the mean equals the median. When the data is skewed right, the mean is greater than the median. And when the data is skewed to the left, the mean is less than the median. Now, comparing the mean to the median is really just getting fancy. What you guys need to be able to do is find all of this information from either a box plot or a dot plot. And then use that information to compare different sets of data. And I think that you can do that.